Hi everyone, welcome back to my channel. Today we're going to be talking about the stringr package in R, which is used for character string manipulation. So in coding, strings, also known as character strings, are sequences of characters that are surrounded by quotation marks. It often includes letters and it can also include numbers. Character strings are often used for names and categorizing your data, and so it can be extremely useful to learn how to work with this type easily. So we're going to start off with our empty RStudio screen. I've got my script on the left and the console over on the right. First, I'm just going to library in the dplyr package and the stringr package. These are the two packages we'll be working with at the beginning. So a very basic string is the classic example of hello world. It's two words that are within quotation marks. And this represents one character string, everything within that set of quotation marks. But typically when you're working with character strings, you're going to be working with at least a vector of them, multiples. They may even be in a data frame. So let's create our vector. We're going to call it fruits, and it will be a vector of names of fruits. So we'll have apple, banana, kiwi, pineapple, and grape. If we want to get some summary stats of our vector, we can use the functions string count or string length. So these do the same thing. You can see that a string count, it tells us the number of letters, characters within each string. So we have 5 letters in the word apple and 6 in the word banana. If we do string length, we get the same results. We have 5 letters in apple and 6 letters in banana. Now say we want to answer a few questions. So first we want to know which strings end with the letter E. We'll use the function string ends, and then we'll put in our string that we're testing, which is fruits, and what we want it to end with, the pattern, is E. And this gives us a true-false output. So apple ends with an E, and pineapple ends with an E, as well as grape. Next we want to know which strings start with the letter A. So we'll use the function string starts, and again, we'll put in the string that we're testing, which is a fruits, and the pattern that we want to look for, which is that it starts with the letter A. And again, it gives you a true-false output. So apple is the only one of the fruits in our list that starts with an A. So that's the only true, and the rest are false. Another question we can answer is, do any of the strings have a certain pattern in them? So for example, we want to find if there's any strings that have the sequence of letters PPLE in them. So we'll use the function string detect. Again, we're going to input the string that we're testing, which is fruits, and then our pattern is going to be in quotes PPLE. We can see that both apple and pineapple have this sequence of letters. This might seem like a trivial example, but later on, when we look at data frames with characters, the string detect function can be very useful for filtering through and subsetting your data. You can also quickly convert all letters to the same case using string to lower or string to upper. This can be handy for making all of your text uniform, so it's easier to match up or group by later on. So all you have to do is input the string that you want to change into the function, and you can see that it changes everything to lowercase or everything to uppercase. So now let's do a little more manipulation with these strings. Let's say that we want to rename something, and we need to split up our character strings and pull out some of the text. This is very common when you're dealing with maybe labels or categories of your data, and you want to rename them or restructure the names quickly. So we're also going to need to library in the package per, which allows us to apply functions over vectors and lists easily. There will be a tutorial coming up for the per package, more in depth, so keep checking back for that. So we're going to library in per, and then we're going to create a new string. This one, we're just call my string, and it's going to be a vector of days. So we'll do day 01, day 02, day 03, and day 04. One of the benefits of using the stringr package is that it's part of the tidyverse, which means that it has the same syntax and structure as other tidyverse packages, and it maintains a coherent structure. So this allows us to use the piping function. So we'll start with our string, my string, and we're going to pipe that to the string replace function. This will allow us to replace the word day with the word sample. So for the argument pattern, we want to put in the text that we're trying to replace. And for the replacement argument, we want to put in the text that we're replacing it with. So sample. So next we will then pipe those results into the next function, which we're going to do string split. So now say we want to split each text where the underscore is. So we want to get sample and then the sample number separated. So we'll use the string split function, and our pattern is going to be what we want to use to split the string. This can be tricky when you have longer strings and if there's no consistent pattern, but if you have things labeled in a consistent way, you can easily use this function to split your text. So for us, we're going to use string split, and our pattern is going to be the underscore because that's where we want to separate it. We want it to be day and the number into two different strings. So we can run that part real quick, and we see that we get a list, and within each element in the list is two character strings, the sample and the number. And let's say last we want to pull the sample numbers. We don't need the word sample because we already know it's the same for everything, but we want to pull the unique sample numbers. So to do that, we'll use the map function, which is the tidyverse version of the apply function and the lapply function. So we will use that, and we will use the number 2 to tell it we want it to pull the second element from each object within the list, and that will give us the numbers. We run that, and we see now we have a list of the sample numbers. If we wanted to get this back into a vector, we could just add the function unlist at the end. Okay, so now we're going to get into a little bit more advanced string manipulation. So we've learned how to manipulate and summarize our strings when they're in a vector. However, it's much more common that you will have maybe a column or 2 or 3 that are character strings within a data frame. And so working with them with these string functions in a data frame is a little bit different than working with them in a vector, but not that much. So we're going to use the murders dataset in R, which is just a data frame with murder rates for each state in the United States. It's in the package DS Labs, so we'll library that in and then call the dataset murders. So we'll just run the head function here, and you can see what it looks like. So in the first column, we've got state. The next one is the abbreviation. The third one is region, and then we've got a population and a total column. The first 2 columns are character strings, and the third one, region column, is actually a factor, but it can very easily be changed into a character type because, as you can see, it's made up of characters. So a common task that you may want to achieve is to pull out rows of data frames that meet certain criteria. To do this, based on strings, we'll need to use a combination of the filter function and the string detect. So say we want to pull out all of the rows that have states that start with the letter A. To do this, we'll start with the murder data frame, and then we'll pipe that into the filter function. And inside of the filter function, we're going to use the string detect function. And for the string, we'll put the name of the column that we're filtering by, which in our case is state, and the pattern that we're looking for, which, as we did earlier, our pattern is capital A, and we know that using a capital A will give us the ones that start with an A. Okay, so we run that and we see that it gives us Alabama, Alaska, Arizona, and Arkansas. Perfect. Now, say we want to find the states that start with A or B. This is a little trickier. To do this, we're going to do the same exact thing as we just did, except for in the pattern section, we're going to add the OR symbol, this vertical line, and B. And we don't want to do a vector of character strings. We want to do it all in one string. So our pattern is A or B. So we run that and we see that it gave us states that start with A or B. So now let's say we have a separate vector, which is states that we're interested in. For this example, I'll use states along the Gulf Coast, right? So in our vector, we have Texas, Louisiana, Mississippi, Alabama, and Florida. Those are the 5 states across the Gulf Coast. If we want to filter the data frame for only those 5 states, we can use that vector as our pattern, but we need to change it up a little bit. So first, we need to actually collapse the multiple character strings into one long one, as we did with the A or B. So to do that, we'll just use the paste function, and we're going to put the name of the vector, which is states of interest, and then we're going to collapse it. And when we collapse it, we want to separate it by the or symbol. So this will actually give us one character string with each state separated by the or symbol. So it reads like Texas or Louisiana or Mississippi or Alabama or Florida. So now that we have it in one character string, we can put that into our pattern in the same code that we ran above, and it will pull out the 5 Gulf Coast states. One last filtering function you can do is sometimes it's easier to remove the rows that you don't want rather than search for the rows that you do want. So for example, in this data frame, say we want to get rid of the states that start with A or B. To do that, we could either do the states that start with C or D or E or F all the way through to Z, or we can do what we did above, which was the A or B pattern, and then we can add this argument negate equals true. So negate equals true actually will tell string detect to do the opposite of the pattern that you gave it. So in this case, it will find everything that is not A, that does not start with A or B. So we run that, and we can see that indeed it leaves out the first couple of states that start with A or B and keeps everything else. Another common way that you may need to manipulate a column of character strings is if you want to change the words. So for example, in the murders data frame, let's change the names of the regions so they're all one word and all lowercase. First, let's just look at all the different regions and see what is actually in that column. So we'll use this distinct function. It's very similar to the unique function, except for it's just the tidyverse method. And we see that there's a south, west, northeast, and north central region categories. To change the name of the regions, we're going to combine the mutate function and the string replace function. So let's start with the murders data set. And then we're going to use the mutate function because we're working on an entire column in a data frame. And the column that we're mutating is the region column. So we're going to add that in first. And then what we want to do to it, we're going to put on the other side of the equal sign. And what we're doing is we're using the string replace function to replace the pattern south with a capital S to south with a lowercase s. And our string that we're replacing it with is the region column. If I wanted to create a whole new column, I could, on the left side of the equal sign, put the name of the new column I wanted, and then this would leave the original region column unchanged. So you can see now that after we run it, the states where they're in the south is now all in lowercase letters. So that's great. So say we want to change all of them at one time. We just need to change the string replace function slightly, and instead of string replace, we'll do string replace all. And this is because we have multiple changes that we're trying to make. So inside of the string replace all function, we'll have our string, which is again the region column. And how we want to change it, we're going to create a vector of that. So on the left of the equal sign, we'll put what the original text is, which is south with a capital S, west with a capital W, north central with capital N and C, and northeast with a capital N. And to the right of the equal signs, we're going to change it to what we want, which is each one lowercase. And for north central, we're going to remove that space and replace it with an underscore. So when we run that, we can see that it did change all of our regions. So now we have all the regions labeled in all lowercase and one word. If you found this video helpful, please like and subscribe and check back for more tutorials later. Thanks, bye.